7. Today's webinar, we're going to be talking about creating intelligence from data and essentially about turning data into insights. How do we turn data into insights? So what do we do? Pluto 7, we are an ML and AI partner for Google Cloud. So what that means is essentially we, along with Google Cloud, work on priority workloads, which essentially involves a lot of artificial intelligence use cases, machine learning use cases, and analytics use cases. To build any kind of use cases on top of these three layers, we need data, and that's where we come in, and we're expertised in that. Google's also named us one of the preferred partners in this domain, and which is why we are here for this particular webinar. A little bit about us. So we started in India just about in the end of 2018. We've got a huge amount of brands right now with us working on building the data warehouse or analytics, or it could be machine learning use cases. Essentially, we work as a services partner, and we build our technologies on top of Google Cloud. And customers come to us with specific use cases, and that's where we help them out. So these are some of the customers, and this is how we're helping them. We are either helping them with a specific use case, or we're helping them to improve their product or their technology by using the Google Cloud platform. Moving ahead, so what do we do? So we essentially work with multiple domains. So it could be retail, it could be e-commerce, it could be internet businesses, manufacturing, supply chain. That's a sector which is growing across consumer goods and insurance. We have multiple clients in this domain, which I just shared before this. And we work on specific use cases. So some of the use cases I'm going to highlight right now. So when we talk about use cases, it's about getting the data in place and then working on top of the data to build these use cases. So demand sensing, demand forecasting, this is a very common use case which we get across different domains and verticals, is essentially taking in historical data of your sales and then predicting for the future. Similarly, revenue forecasting or identifying what is the kind of pricing to do at the right time, at the right place for the right customer. Right? So essentially, it's looking at all of the historical data. It's understanding the data. It's understanding the pattern in terms of a graph where to plot it across, and based on that, predict what the future is about. Post that, we got into different departments of the organization. So marketing department is a very important department because they're generating a lot of data. So here we help out certain customers. I won't name the customer, but some of the use cases is we can improve your email campaigns, conversion rate optimization. So what essentially we can do is we can see a pattern of what your emails open rates are or click-through rates are, and tell you which customers to send what emails to, and personalize each and every interaction with the customer. There are multiple things on top of this which we'll be covering in today's webinar. And how, once you have the data and structure, once you're capturing all of this information, how you can make it real with machine learning, AI, and analytics, right? Post that, supply chain, this is an area which we started our business with. Supply chain essentially involves delivering the customer the product at the right time. And here, essentially from demand forecasting, which is identifying what is the total demand which you have for your future forecast, to actually even identifying what is a quality product to deliver for your customers. So some of the use cases which we're delivering for one of the largest companies in the world, I can name the customer, it's AB InBev. We are essentially taking all their data from all the manufacturing processes where they are capturing information through IoT devices, and we are identifying what is the best manufacturing process, or where exactly they'll have the least amount of outages. So these are some of the use cases which are solving for manufacturing using supply chain ML. And sales, which is a very important component in the business. We are identifying which customer is going to buy what kind of product, which customer will return to you, and which customer will essentially be a customer which you need to give more amount of discounts or services to make him attached to your brand. Reducing churn essentially, and what kind of sentiment is there in the market for your product or brand. Moving on,
Hi everyone, I'm Arsh. I'm the senior marketer for Pluto 7, and then Hi everyone, I'm Arsh. I'm the senior marketer for Pluto 7. I guess my voice lost out. We're going to be talking about the principles of big data and how you're going to be implementing a data warehouse and analytics engine on top of it. So, big data is in Google's DNA. With over 1 billion users across 8 products, Google handles a lot of data. And all of this data has to provide meaningful insights in real time without a single chance of failure. So the way Google handles its data is in a pretty robust way. And that's what it's offering to all of its potential users on Google Cloud. So when we move on to Google Cloud, we can rest assured that our data is being handled in processes that are not only scalable but also robust. Whether you're small, whether you're big, it's all sorted in one equivocal way. All of these technologies, they run on the same proven and reliable principles that have powered Google across these years and that have enabled it to become one of the biggest players in the tech market. According to IDC in 2017, 163 zettabytes of data is going to get produced by 2025. I mean, that sounds like a very big number, but to make it more understandable in context, imagine a cat video. The cat video will have to be twice as long as the current age of the universe for it to be 163 zettabytes. That's a lot of data. And by 2025, all of that data needs to get processed. And Google Cloud is one of the most easiest way of ensuring that you have frameworks that can take in this data and provide you meaningful outputs out of it. One thing that's also becoming increasingly clear as we're meeting enterprise business leaders from all around the world is that we all agree that machine learning is becoming a necessity, as the right ML strategy can put businesses way ahead of their competition and give them the edge that they need to succeed. According to a recent study by Bain, companies that use ML and analytics are 2 times more likely to make data-driven decisions, 5 times more likely to make these decisions faster, and 3 times more likely to execute these decisions that are based on their data. So in total, 46% of IT leaders and 50% of machine learning adopters have got demonstrable ROI by having a competitive edge using AI and ML. According to Harvard Business Review, if your company isn't good at analytics, it's just not ready for AI. So the next step in the journey after managing the data coming towards you is to know what questions to ask and what insights to generate by adopting advanced analytics. But conventional data analytics platforms, they fail to live up to data growth. I mean, they're just not built in a way that they can withstand all that much data. In fact, less than 1% of unstructured data is analyzed or used at all. And less than 50% of structured data is actually being used to make decisions. So how does Google handles it? So there are 4 key design principles for Google data analytics that lets you circumvent all of these errors. The first thing is it's serverless. Google is designing analytics solutions for the public cloud paradigm. They're not just lift or shift or traditional on-premise architecture. Google's serverless approach has allowed customers to keep their focus purely on analytics and move away from the infra build, the management, and all of those things that are just hindering you and not giving you real value. Automated data transfer can help you extract data from a system, share it with whoever is federating your querying across any of our Google services. It's the second main design principle is that the Google data analytics stack is comprehensive. The Google Cloud Platform offers a comprehensive set of core data analytic workloads, from data warehousing to streaming data analytics to data processing, preparation to business intelligence to AI and to ML. Unlike vendors with one-off solutions, probably like Snowflake, Google looks at analytics stack much more holistically. It understands there are a lot of moving pictures and they all need to talk to each other for you to get actual value. The third paradigm is the E to E ML lifecycle. Google lets its customers operationalize machine learning end to end. ML training and prediction is just a part of the puzzle. Customers can seamlessly collect, store, transform, process, and prepare data from ML. And Google is deliberate in its attempt to make ML lifecycle simpler and staff so that organizations can derive more value from their ML initiatives and they can do it faster. Fourth main design principle is that it's all proven. We understand this, and Google has been at the forefront of data analytics and ML innovation for the past 2 decades. In fact, Google Analytics is the go-to analytics source for any website. That's your source of truth. And it is those principles that Google wants to apply across all business functions, not just marketing, not just your website, not just your sales, everywhere. The solutions and frameworks which have been proven at Google now are being used by one of the world's most innovative companies, and they are running mission-critical analytics apps on Google Cloud. Enterprise data warehouse stores the most valuable data for your company, and it brings AI capabilities without replicating data into storage. Serverless data analytics, from infrastructure to platform for insights. It brings the data, you can just bring your data in and start analyzing. No need to wait, no need to understand the infrastructure, just get your data in and start getting insights. It's as simple as that. Google Cloud also offers you a complete foundation for your data lifecycle, from data ingestion all the way to end analytics. For data ingestion, you have Cloud PubServe, which is a scale messaging platform. You have Data Transfer Service, which is an ADS data for Marketing Cloud. You have Beam, which is a stream and batch processing with single programming model with data flow. You have Data Proc, which is a managed Hadoop and Spark platform. Then again, you have Data Prep, from which analysts can now do preparation using just a visual tool. They don't have to write code or anything. And then you can use BigQuery as a data warehouse, and then Google Cloud Storage as your data lake, whether for its structured data or its unstructured. And then at the end, you have Cloud ML Engine and TensorFlow working together for machine learning on top of all your data on BigQuery and Google Cloud Storage. And then all of the insights that the machine learning is going to give you, you can visualize it via Data Studio or transform them into actionable Excel sheets via Google Sheets. Google Cloud also offers serverless analytics for your complete ML lifecycle. Data scientists on average spend 80% of their time in data preparation and only 20% in the actual model building. This platform is for data scientists to ingest, explore, prepare, and process their data without having them to spend all of their time in actually just preparing the data. You can seamlessly build ML models, test them, tune them, and operationalize them as and when they are necessary. Google Cloud is in the big data ecosystem for the last 15 years, starting all the way from research papers, moving on to open source work, and then finally coming up with BigQuery in 2010. And then in 2014 to 2018, it has really gone in involving machine learning and AI capabilities on top of your data, coming up with PubServe, Dataflow, Bigtable, machine learning, and then Spanner. Google Cloud is also gaining a lot of momentum across some very big companies in the world. The main verticals it includes are financial services, retail, gaming, media, and entertainment. Twitter, in fact, all of Twitter is based on Google Cloud. It's the largest Hadoop cluster with over 300 petabytes of storage. Google Cloud companies include native companies which have been completely built on top of Google Cloud, as well as large enterprise customers who are only offering certain parts of their business process to Google Cloud, optimizing them and getting the data back into their existing service. Data analytics solutions from Google Cloud cover your whole spectrum, whether it's modernizing your data warehouse foundation, analyzing your streaming data in real time, running powerful open source data solutions, or visualizing and activating your existing data. BigQuery ML empowers data analysts and data scientists like nothing before. You can execute ML initiatives without moving data from BigQuery. You can continue iterating on models in SQL to increase your development speed, and you can even automate your model selections as well as hypertuning. Google Cloud Platform offers serverless solutions with powerful streaming data analytics. You can ingest them. Cloud PubServe is a simple, reliable, scalable foundation for stream analytics and event-driven computing systems. As part of Google Cloud's analytics solutions, The service ingests event streams and delivers them to Google Cloud Data Flow for processing. For transformation, Cloud Data Flow is a fully managed service for transforming and enriching data in real time, as well as historical modes, batch processing that is, with equal reliability and expressiveness. And then you can also analyze your data. Google BigQuery lets you store and analyze all your real-time data stream. You can analyze streaming data sets with custom-built machine learning APIs or some pre-trained machine learning APIs with equalies. It's entirely up to you. Google Cloud Storage is also one of the most powerful open source solutions in action when it comes to data lakes. It offers you data storage. You can store massive volumes of structured and unstructured data very economically. You can do ad hoc analysis on, again, whether it's structured or unstructured data. You can process your data, or you can provide ML-based advanced analytics, whether it's image recognition and classification, voice translation, handwriting recognition, video stream analysis. I mean, you can do whatever you want to. Then business intelligence. So Google Cloud's analytical framework also involves business intelligence. It involves you visualizing and activating your data. You can realize self-service BI with choice and flexibility, explore your data your way at scale, no pressures, take your time. And then you can create a collaborative data-driven culture to democratize data across your company. From the lowest intern to the CEO, everybody should know what's happening. And you can do that with Data Studio. Google has also been made a leader in insight platforms as a service. In fact, the Forrester report said that their evaluation identified one vendor as a leader based on the strengths of its past strategy, advanced tools for batch and real-time solutions, and machine learning and AI offerings. So that was all about big data and how Google Cloud Platform can let you make more sense of your data irrespective of what size it is in. So I'll be now passing it on to my colleague Nikhil, who will walk you through how we have worked on with a lot of companies and have given them meaningful insights. So moving to you, Nikhil.
Perfect. I'm just going to be sharing my screen. Yeah, hi guys. So talking about the success stories or what we have seen of companies looking at using big data or machine learning and AI to further enhance or digitally transform their business. These are some of the use cases which I'm going to be talking about, or probably this I'm going to put in such a way just to throw light into how these companies have made it real for them, right? I mean, they have data in place, and how are they making it real for them? So the first company is basically a large matchmaking portal. I can't name the customer because it's still in progress in terms of the delivery of this particular deal. And where we are helping them is to proactively analyze what kind of customers are churning out. We are also identifying a lot of traffic from multiple sources. I mean, in terms of tier 2, tier 3 cities, a lot of sources are now coming onto matrimony portals and trying to figure out matches. And another use case for us that was given to us is converting these free users into paid users. So if you're on a matrimony portal, you're ideally, you're seeing a bot within the backend, which is trying and experimenting from user patterns as to how we can convert you from a free user to a paid user, right? So this is a complete AI-based framework. This is the architecture which we use in place. So essentially, in a matrimony portal, maybe this image won't be clear, but it's identifying what kind of age group you're from, what is your marital status, whether you have children, or like what height you're, all these different aspects of you, right? In the backend, there is a bot which is understanding each and every pattern of you as a user. And based on what is your past behavior with the matrimony site, it is automatically pinging you. So there's a bot which is built on an AI framework. We call it Dialogflow in Google Cloud ecosystem, which is going in the backend. It's identifying all these different user patterns. It is identifying different users who could possibly find, it could be possibly a match for you. So kind of like a recommendation engine. And by that, it is looking at how two users can be matched together. Second is, if you have not shown any activity on the portal, it'll automatically ping you with the right kind of profiles which it sees as a match or potential interest which you will show. And to the level, even if you're not happy with your profile or your matches, it'll go back in the back end, it'll check what kind of matches would ideally be able to suit you, or which profiles you actually looked at in positive light, and are these profiles something it'll keep throwing you all these kind of profiles as suggestions, and based on your feedback, if those are better matches than what you've been receiving earlier, it'll automatically decide to throw those amount of matches and also try and convert you into a paid user until it further fulfills your requirement by you talking to a personal agent or a human agent. So together in this use case, what we have seen is humans and AI working together to improve a business and digitally transform it from an age-old business of just collecting data to actually working and turning these data into insights, right? So maybe you want to learn more about this use case, you can probably reach out to me. I'll send you my email at the end of this presentation. Second use case, which is one of the best use cases we have worked on, is parts identification. So here the warehouse is all images of multiple parts that lie with one of the largest automobile manufacturers. This is a two-wheeler automobile manufacturer. And essentially what we are doing, at least on the cloud side of business, is we're identifying each and every image, and we are training the AI to identify each and every image based on the image training data set that is given to us. By this, we are basically classifying the image for a certain part ID, right? So the whole use case is that how can we do better warehousing, or how can we do better packaging or labeling, or avoid incorrect packaging by using an AI, right? So humans tend to, I would say, get complacent with certain amount of parts. So for example, one part will be a green line versus the same part, and the same part ID will be a red line for a different product, right? So it could be like something like a headphone. However, a headphone version 2 is a different product SKU ID altogether, right? Which has different packaging, which goes to different dealers who have placed orders. So in this case, how we're doing it is, one is on the training data set where we're loading all of this trained, or I would say all of the images of each and every part. We're loading it into the warehouse, which is basically a storage layer, which hardly cost anything. So for like, I believe in the Google Cloud ecosystem, for 1 GB, it's hardly 1 cent, which is, or maybe for 1 TB, it's hardly a cent of cost. So which is why we could load millions of images, almost 50,000 images for 25,000 parts. So 50 images per part into this particular storage bucket. And by that, we are training the AI to understand which part is which part is which part ID, which image is which part ID. And on the prediction side, which is this diagram, which you can see on premise with a conveyor belt. So a conveyor belt is having multiple vendor parts, and each of them are going at a latency, or I would say at a speed of 20 parts per minute, 20 to 30 parts per minute, which gives us around 2 seconds to 3 seconds per part to identify which part and tell the warehouse management system that this is the part ID. So in this case, we have 3 cameras placed on the conveyor belt, which is already trained. So technically, this is an edge kind of framework, which the conveyor belt is automatically. I mean, at the conveyor belt, at 1 second to 2 second or millisecond kind of intervals, we are identifying the part ID, and through an open API framework, we are passing that part ID to the warehouse management system, which is eventually either labeling the part, or it's showcasing a discrepancy or an anomaly in the warehousing process, right? So for example, if you throw out a different part, take for example, there are only plastic parts and then a sudden metal part or a ball bearing, which you would see on the conveyor belt. And if that is in the packaging, it'll automatically throw out a different sound from the warehouse management system saying that, hey, this is a different part and this is not part of the same batch. So these kind of things, we are able to reduce the faulty packaging, and by this the warehouse will be more streamlined and organized, and that's something which only an AI can do, which has a huge data warehouse background in the backend. So that was one example which I wanted to take to you across. Another example is for for a large, I mean, you can see by the model which company it is, but it's for a very large manufacturing company, which is the top manufacturer in India and manufactures the largest amount of vehicles. And they would give us a lot of data related to the electric vehicle. They are probably next year or a couple of years from now, they'll be releasing electric vehicle, which has a lot of data which is passed through a canvas methodology. So a canvas is kind of like a controller which is within the car, which is passing all the data through a GSM framework, right? Through a GSM network to us on the cloud. So essentially what we wanted to do is in real time identify what is the forecast, or what is the accuracy of the car charging. For example, if you turn on the AC at certain amount of temperature where the outside temperature is certain amount, what is the pressure which the battery would have? And these are all lithium ion batteries, right? So I mean, what is the eventual forecast of how much more life the battery has, so that that can improve the customer experience of you actually identifying the electric vehicle, and how much it'll run or how much future capacity it will have, right? So these are some of the new age use cases which we're getting, because most of the automobiles are getting smarter with time, and more. I mean, I don't know if you've visited the new showrooms, but you actually get an add-on device which can be connected to your car, which can tell you a lot more about your car, right? For example, and it can also tell you different kind of use cases where what is the useful life cycle of future parts. For example, clutch, brake, or battery life. What is the eventual usage which you can see, and when to replace these kind of parts, or whether these parts are in warranty and whether you should take it back to the OEM and tell them that, hey guys, it's the part has been faulty and it's in my car, and right now I can't afford a servicing because I'm already in warranty. So there are many new use cases which are getting where customers by themselves are identifying ways where they can use data to better turn them into insights. Another use case is for a large construction company, which has tons and tons of site managers at site. So this is the largest construction company in India, at least. And what they have is a problem where a site manager who's on site, for example, he's managing a metro project, or he's managing one of the largest building constructions in the country. And at any point of time, for him to go back to office and identify how much of inventory he has for doing the construction, or for laying a slab, or for identifying the next phase of the project, he has to go back to office and derive all those data patterns or reporting needs, right? In this case, we are giving it to him on a phone in real time if he just asks the right amount of question. So for this case, like if it's a project ID which is already in status, the bot actually, through a tree structure of queries, it can identify different. So I'll get a little technical here. So it can identify different objects. So for example, what is the planned versus executed, right? So these are two objects in the database, right? But the bot doesn't understand these as objects. These are a typical query type. So how many projects among project ID 101, what is the current status? So it should automatically fulfill a query by saying that, hey, this is the planned activity, this is the executed activity, this is the amount of completion which you've done, right? So all of this, the bot automatically identifies the query type. It fills it with the right amount of objects in the query type and functions, for that matter of fact. And in the backend, what we have done is we have actually written all these multiple APIs to go into the core system of this large engineering company. So it's SAP actually. And from SAP, we're deriving all of these different insights through multiple different query patterns in real time at millisecond kind of intervals. And by that, we are attaching these two queries and we're throwing it out onto a mobile phone in like some millisecond kind of latency. Right. So this is something which is pretty incredible. I mean, and we're using Dialogflow and Google Actions in the backend to create all of this entire structure. And probably if you meet me in person, I could show to you on the phone and see, whether this is something which your organization would want to do or would want to achieve. And we are seeing a lot of use cases like this, where Google Assistant or some of these bot-based tools are used for making the data more insightful for the person at site. Right. So here I'm going to pass it on to my colleague Ash, who is going to be talking more about BigQuery and the tool which does this.
Hi everyone. So we'll now be covering BigQuery and how it's going to be acting as a data warehouse for an AI-first strategy across your business. So before moving in, what exactly is BigQuery? So BigQuery is Google Cloud Platform's enterprise data warehouse for analytics. It's very convenient, quite similar to the standard SQL. It is fully managed and is completely serverless. It has a petabyte scale storage, and you can query also on a petabyte level. It's encrypted, it's durable, and it's highly available. And the final thing is, you can have real-time analytics on your streaming data. You don't have to wait for your queries to come back. You don't have to wait for your data to get in. You can just get your data, your analytics as and when you require them. Machine learning is BigQuery is also building a foundation for a machine learning based data warehouse. So back in the 90s, data warehouse, the first gen EDWs, they help you increase your analysis. They made data collection a more comprehensive process, but they still lacked a lot of stuff. In the 2000s, these data warehouses, they laid the foundations for BI. Right now, BigQuery is already there, and you can do a lot more stuff than you were able to back in the 2000s. You can put a lot of AI on top of it. But in the future, the ML layer is going to be pre-existing in BigQuery. I mean, we want you to start with ML and then move forward. So what are the key challenges that are affecting ML today? The basically main two problems that's underlying state of machine learning. The first is that it requires data scientists, and there are just too few of these. And the second is that it requires setting up of multiple tools, complex, time-consuming, moving data out and formatting it to the Python framework you may be using. So both these two challenges is what mostly holding the companies of today in adopting ML across their processes. And that's where Google Cloud come in. It makes ML accessible for all audience. The goal is to enable developers to easily infuse AI into existing applications or build entirely new intelligent applications for a large spectrum of use cases. We want to make these capabilities best in class in the industry, and with Google Cloud's comprehensive set of building blocks, we can't wait to see what our developers can create. With ML, you can bring it with ML, BigQuery, you can bring ML into your data. You can use a familiar SQL for machine learning. You can train all your models over their data in BigQuery, and you don't have to worry about hyper-tuning or feature transformation. Some of the top use cases which involve BigQuery as a data warehouse would be Heart newspapers, where they use BigQuery to predict customer churn, and then 20th Century Fox, who optimize their media plan for new movies, looking at the propensity scoring of particular audiences. They use BigQuery ML so that they could optimize their marketing and media spend. GeoTab created an app using MQL plus BigQuery for smart cities. It's a plugin that tells if there's going to be aggressive driving or accidents, combined with weather data. News UK enable better customer subscription prediction, which are the people who are more likely to convert into subscribed customers, or which are the people who are just there to read through one news. Smart parking enabled traffic prediction for smart cities. Reblazed enabled automated IP address threat prediction. So there's a lot of work BigQuery can do, and it's across any use cases. So more or less the only thing that's holding you is your own imagination. Some of the supported features of BigQuery include standard SQL and UDFs within the ML queries, linear regression, that's forecasting, multinomial logical regression, that is classification, model evaluations, functions for standard metrics, which also includes the ROC curve, model weight inspection, and feature distribution analysis through standard functions. BigQuery is also available through all of our existing BI platforms. It enables Tableau, it has Looker, it even has its Google Data Studio, and even if you're using outside clouds, whether it's Salesforce or whether it's Microsoft Azure, you can still pass all of your information in. So even if you're using Power BI, it can be powered by AI-driven insights from Google Cloud. There are so many possibilities to be protected. I mean, if you're looking at marketing, you can predict customer lifetime value, you can predict funnel conversion, you can personalize ads, emails, web page content, depending on the behavior. For industrial and IoT use cases, you can forecast demand, you can predict maintenance need, you can even prevent equipment downtime. For media or gaming industries, you can personalize the content, you can even predict how difficult the game's going to be, and you can predict the player's lifetime value. For retail, you can optimize your inventory, you can forecast how much revenue is going to come in, you can enable product recommendations so the right people are offered the right products, and you can even those little things that your staff members are doing that's actually pushing the sales but is not getting recognized. You can offer them promotion based on that. So that was all about BigQuery. And then let's get to the main part. Getting started in bringing AI in. So who can actually use AI today? Very few customers today can create a custom ML model. I mean, out of the 21 million developers, there are less than 1 million developers who actually have any prowess in building customized ML models. AI, it needs to be accessible to millions of more people. That is when. So how can Google inject AI into your business? Google Cloud AI is no longer in its infancy. We built a robust portfolio of products that solve a multitude of customer challenges. Google is also very fastly growing its product portfolio, and mostly in three main buckets to help you reach the core users who are using AI right now. One of them is building blocks. The second would again, the goal is to enable developers to easily infuse AI into existing applications or build entirely new intelligent applications for a large spectrum of use cases. Whether it's site, you have Google Cloud Vision, Google Cloud Video Intelligence, and then AutoML Vision, which is fairly new. Then for language, you have Cloud Translation, Cloud Natural Language, AutoML Translation, and then AutoML Natural Language. And for conversation, you have Dialogflow, Cloud Text-to-Speech, and Cloud Speech-to-Text. Google Cloud AutoML is an ML that lets you create ML for your problem. So whatever your use case is, whatever your pain point is, it lets you train an ML specific to your need. You can train, deploy, serve, and then generate predictions with a REST API right on your fingertips. And then now we'll explore some of the top use cases with machine learning that Google has worked with. So in cases of manual, it would be maintenance or monitoring, how much warranty is left, propensity to buy, demand forecasting, process optimization, and then telematics. For retail, we have predictive inventory planning, recommendation engines for offering products that a customer is more likely to buy, upsell and cross-sell marketing, market segmentation and targeting, customer ROI, and lifetime value. For healthcare, we have alerts and diagnostics from real-time patient data, disease identification and risk stratification, patient triage optimization, proactive health management, and then sentiment analysis for your healthcare providers. For financial, we have risk analysis, fraud detection, creditworthiness evaluation. Then you can segment your customers, upsell, cross-sell, and then make more efficient sales and marketing campaigns. For travel, you have aircraft scheduling, dynamic pricing, social media-based consumer feedback and interaction loop, customer intervention required, and then traffic patterns and congestion management. Then for energy, you have power usage analytics, how much power is going to get consumed, how much is it getting consumed, what's the optimum consumption that you should aim for, seismic data processing, carbon emissions trading, customer-specific pricing, smart grid management, and then energy demand and supply optimizations. So Google Cloud AI have built a very robust portfolio of products, and it lets you ingest your data, process it, and analyze it. And there are specific solutions that handle each part of this whole funnel. So for ingestion, you have Android Things, Cloud IoT Core, and Cloud PubServe. For processing, cleaning, and storing, you have Dataflow, Cloud Functions, Bigtable, Spanner, and then Google Cloud System. For analyzing, visualizing, and predictions, you have BigQuery, Data Lab, the ML Engine, Data Studio, again, Cloud Functions, and Cloud Dataflow. Google Cloud works across IoT devices. I mean, that's the whole idea. irrespective of whether it's a physical or a digital data source, Google Cloud can connect to it, understand what's happening, and then provide you insights by training custom ML models. So I'll now be giving it to Nikhil, who will walk you guys through on how exactly can Pluto 7 help your company get BigQuery and advanced AI in place. So giving it to you, Nikhil.
Perfect. So some of it, I mean, maybe we've rushed through all of these components. Definitely each and every component very important in its own way. So, for example, Cloud Functions, which makes your whole architecture serverless, or Dialogflow, for the matter of fact, which is the bot building component of Google Cloud. Each and every component is very important in how you bring the architecture together. So who does all of this? So essentially engineers who are qualified on the Google Cloud platform, right? So that's where we come in as well. We are a premium partner with Google Cloud. And what we do is, I mean, we would recommend that you try it out for yourself. Go get onto the cloud platform. If you want to reach out to me, you can reach out to me. We'll give you a couple of hundreds of dollars free of cost for you all to explore it further. And Google by themselves gives you $300 credit to go ahead and explore the platform. There are multiple products which you can use. Where we come in and where we make it real for you is basically doing three things. One is either conducting a workshop or something like a POC for centralizing the data which you already have, you're capturing, or you're not capturing, and you want to identify a place where you want to capture it and then make sense out of it, turning it into insights. Like the paths identification use case which I talked about, right? There were no cameras that were there. There were no capturing of data that is currently being done. We've got the cameras in place through a vendor, obviously, and they already have existing vendors to do that. Once we got the data, we're working on it to create the training kind of infrastructure and then creating the prediction kind of infrastructure. So similarly, we would recommend you all to actually take the first step, try to derive insights out of the data, and where you'll need expertise, if at all you'll need expertise, or if you'll need any specific area of architecting it better, or making more sense out of the data, or probably deriving more values on the BI layer, or on the data layer. That's where Pluto 7 will come in and help you organize it better. In terms of machine learning and AI, I mean, it's essentially the use case, right? So if you give us a use case which is that you can derive more value out of it. It could be sales forecasting. It could be, it could be solving a maintenance issue. It could be you're growing e-commerce business and identifying how I could grow it further, or you want AI to probably improve your revenue. So many kind of use cases which you are coming across with, or which you are finding difficult in doing it. That's where you involve us, and we can see if it can be architected better on the cloud, where we can transform your business with strategy plus technology consulting, and making it real for you. So that's essentially what we do. This is my contact details. You can reach out to me anytime. I'd be very happy to solve any kind of query for you all. It could be the most stupidest query. In fact, I love those. And just reach out to me. You have my cell phone number. You have my email ID. And if there is any problem, I would either direct you to the right people at Google or at Pluto 7, and we could take things further. So thank you so much. A little bit more information which you need to look for. All of this information is available on Google Cloud Platform. There's our training websites, which you can learn more about all the technology which we spoke about. So that's on Coursera. That's Google's training partner. And do reach out to us and me for any more information with regarding specifics. Thank you so much. Thank you for your time. Bye.